So, Simon AH4V calculator is allowed. Number 1. N is a positive integer. Prove that this expression is an odd number. So the way I would approach this, I'd look for factors. I'd try to factorize to make the whole thing look simpler. So looking at the top, we see that n is common. So I have 2n squared inside the bracket plus 3n minus 2. That's the numerator. And then on the bottom of the fraction, denominator, n is common again. And inside we have n plus 2. Now, looking at the top, that the bracket there is a quadratic expression which we can try to split up into 2 factors. All over n times n plus 2. And with practice, these become all right. 2n squared must be 2n times n. And then we look at the constant, minus 2. Well, it's 2 times 1, but you can either go 2, 1 or 1, 2. And you try it by trial and error. We find that it's 1 there and 2 there. I want plus 3n, so it must be 2n times 2 is 4n. So plus there to give plus 4n, and then minus there to give minus 1n. Altogether will give me plus 3n, and then minus 1 times 2 is minus 2. Then I look, what can I cancel? N with n. And also I can cancel n plus 2 with n plus 2. So it simplifies down to 2n minus 1. And what can we say about 2n minus 1 if n is an integer? Well, 2n will be always an even number, because an even number is 2 times something. So 2n minus 1 is a number just before an even, which is always odd. 1 less than an even number is always odd. Question 2. The speed of light is 300 million meters per second, and the distance from the Earth to the Sun is 150 million kilometers. Be careful, kilometers mixed up with meters. How long in seconds does it take light to travel from the Sun to the Earth? Velocity of the light is 300 million. I think I'll work in powers of 10. A million is 10 to the power 6 meters per second. Next, the distance from the Earth to the Sun is 150 million kilometers, but we know that 1 kilometer is 1,000 meters. So we're going to work all in meters. So 150 million for the distance. This 150 million means times 10 to the power 6. And to change kilometers into meters, we will multiply by another 1,000, or 10 to the power 3. Put our units in just to be correct. So how can we get the time taken to travel that distance at that speed? The time taken will equal the distance divided by the speed. So it will be 150 times 10 to the 6 and 10 to the 3 multiplied together is 10 to the power 9, divided by the speed of light, which is 3. I can split up the 100 there. I can call it 10 squared times 10 to the 6 is 10 to the 8. And now I can see where that takes me. 3 into 150 is 50. And 10 to the 8 into 10 to the 9, you subtract the powers, you get 10 to the power 1, or 500. And because we're working in meters per second and meters, this time is in seconds, which is what we were asked to find, so that's the answer. In the formula, t equals n minus 5 squared plus 7, n is a positive integer. Kate says The value of t is always greater than 7 because n minus 5 squared is always greater than 0. Comment on her statement. Well, to put it bluntly, Kate is wrong. And she's wrong because she says it's always greater than 0, but in fact, if you look at n minus 5 squared, that expression can be equal to 0 when n is equal to 5. Right? And so, if that expression there equals 0, then t can be equal to 7. So t can be equal to 7 in the case when n is 5. So it's not true that what Kate says, she says it's always greater than 7. So it can be greater or it can be equal to. Next part, part B, what is the only value of t that is a square number? So looking at t there equals n minus 5 squared. Of course, n minus 5 squared is a square number, plus 7. So this is all about square numbers, so let's write down the first few square numbers to help us to see how we can approach this question. Square numbers begin with 1 times 1, which is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, next one is 36, and so on. Now looking at these square numbers, we can see that from one, we've got to go from one square number to the next. I can see that, let's work out the distance, the difference between one square number and the next. 1 to 4, there's a difference of 3. 4 to 9, there's a difference of 5. 9 to 16, there's a difference of 7. Now that's what I want, because 9 plus 7 equals 16. 9 is a square number, and the result is also a square number. So that's what I'm looking for here. T, they want to be a square number which is equal to a square number plus 7, so t is 16. F of x equals 4x. Circle the expression for f minus 1 of x. X equals 4x. That just means you're multiplying by 4. That's what that function does. So we're trying to find the inverse of this function, which means go backwards. And the inverse operation, multiplying by 4, is to divide by 4. It's as simple as that. So you just think, what do I do to divide by 4? It's x divided by 4. And question 5. Y is directly proportional to the square root of x. So if I look at this, y equals a constant times the square root of x. When x is equal to 16, we know that y equals 2. So 2 equals k times the square root of x. Square root of 16 is 4, which in other words means that k equals a half. And y is therefore a half times the square root of x. Working on to the next one, 5 equals a half times the square root of c, using the second set of values. So square root of c, multiply both sides by 2, I get square root of c equals 10. Square both sides, I get c equals 100. So c equals 100 is my answer. Number 6, company makes boxes of cereal. A box usually contains 450 grams. Here are two options for a special offer. You could either have 20% more cereal and the price remains the same, or option B, usual amount of cereal but 20% off of the price. Which option is better value for the customer? You must show you're working. So let's look at option A. 20% more cereal. We started with 450 grams. and we've got to increase that by 20%. So that means multiply it by 1.2, 120%, 1.2. So 1.2 times 450 comes to 540. So in option A, we now get 540 grams for the same money that we used to pay before. The price remains the same. So let's suppose that the price was £1, because £1 is 100 pence. So I can say in case A, I get 540 grams for 100 pence, which tells me that the price per gram, oh no, what am I going to do? Yes, the price per gram is going to be 100 pence divided by 540, which on our calculator comes to 185 and some other digits, but I'll just write 3 places of decimals. And in option B, it just says the usual amount of cereal, but 20% off of the price. So we still get 450 grams of cereal in option B instead of 540. And we get it for 20% off from 100. That's easy. If you subtract 20%, that means you're left with 80% of 100, which is 80 pence. So 450 grams for 80 pence, which gives us a price per gram. Total price is 80 divided by the number of grams that you get, 450. If you do that on your calculator, you find that it's 0.177 pence per gram. So compare the two answers, and we see that option B is better value for money because you're paying fewer pence per gram. So option B is the better value for the customer. Question 7. The histogram shows the ages in years of members of a chess club. So histogram is important. We don't have frequency along the top, we have density, frequency density, and then age along the bottom, 5, 10 as the continuous graph. There are 36 members with ages in the range of 25 to 40, from there to there. Then it says work out the number of members with ages in the range 18 to 25. Important thing with histograms is to realize that the frequency is represented by the area of the bar. So we're interested in the area of that bar there, which I can break up into, I'm going to use the main squares that are showing on the grid. My lines are not the straightest I've ever seen, but I'm going to continue those lines across there to show how many squares, big squares, not the tiny little squares, but the 5 by 5 squares, how many of those we can get in this grey bar. And if you count them up, we find that there are 12, 15, 18. So there's 18 squares represent the number of members we said there was 36. So one square must represent 2 members. So if that's the case, now we look at our other range from 18 to 25. the area now. Well, let's look at this bar. It's a bit awkward. Well, this way, along the vertical axis is easy. 1, 2, 3. There's 5 bars along the top, going from bottom to top, but horizontally we've got a whole square and then we've got 2 little squares. So that is 1.4 units along there. So the area of that bar is going to be 5 times 1.4, which comes to 7 squares exactly. So if 18 squares represents 1 square represents 2 members, then 7 squares will represent 7 times 2, 14 members. Because frequency is proportional to the area of each bar. So we could say there are 14 members in the range 18 to 25. And we move on to number 8. A bowl is a hemisphere with radius 4. Water fills 1/2 of the volume of the bowl. So that volume, the grey volume, is 1/2 of the total volume of the hemisphere. Then the water is poured into a cone, taking up a height of 8 centimeters. They give us the formulae for sphere and cone. Work out the radius of the surface of the water in the cone. That radius is what we're trying to find out. Let's go back to the hemisphere. You say that the volume of the hemisphere, well, hemisphere is 1/2 of a sphere. So we've got the formula for a sphere, so 1/2 of that will be 2/3 pi r cubed. 1/2 of 4/3 is 2/3. That's a hemisphere, but the water is only taking up 1/2 of that volume of the hemisphere. So we've got to take 1/2 now of this expression that I've got here to get the volume of water. It's going to be 1/2 of the 2/3, which is 1/3 pi r cubed. Now I know what the radius of the hemisphere is. Let's just check it. The hemisphere was a radius of 4. So I can put 4 for r there, so it's going to be times 4 cubed. And then you use your calculator to get that. And I think it comes to about 67.0206 and some other digits. When I put ... I suggest that you work with full accuracy in your calculator, but I can't be bothered to write down all 9 or 11 digits on the paper. But when you're working on the calculator, then we can. So now we're working out the height or the radius of the cone. So we know that this is the formula for the radius for the volume of a cone. 1/3 pi r squared times the height, which is 8, must equal the water, which was, we know, 67.02 ... Okay, once again, use the full accuracy with your calculator. From that, we can get R equals 67.02 times 3, divide by pi, and divide by 8. That's R squared, actually. So from that, you can now use your calculator and get the answer for R. And when you do that, you find it's about Is it 8? 3? I'll just say that 2, 3 significant figures. Question 9. A big wheel is modelled as a circle with centre O and radius 14. It turns in an anti-clockwise direction, like this. The lowest point of the wheel is always 2 meters above the horizontal ground. C is a point on the wheel, H meters above the horizontal ground. Angle is X. Show that H is something, so we have to go back to. So we go back to the diagram. We've got to find an expression for H. Let me call this letter here. Let's call that point maybe E. Yeah. Then can you see that OE is equal to 14 because it's the radius of the circle, and from E to B we know is 2 meters, so from O to B is 14 plus 2, 16 meters, right? But from O to B we can get it another way. OB is also equal to H plus the distance from A to O, OA. But I could say, well, so H is equal to OB minus OA. OB is 16 minus OA. We've got 14 for the radius. It's a right angled triangle, so it's 14 cos X. So there's our answer. Should really write the working on the dotted lines. I apologize for that. Part 2, or part B, D is a point on the wheel, and angle DOB equals 150. Work out the height of D above the ground. So I'll put in a horizontal line there and a vertical line from D. If I call that point N, and what else do we know? I know that OB, we already worked that out before, was 14 plus 2 was 16 meters. Now DN, I don't know that yet, but let's look at that triangle. Got the radius of 14 times the sine of that angle. And the sine of that angle is going to be 150 minus the right angle which you've got there. So 150 minus 60. Minus 90, sorry, I'm giving you the answer. 150 minus 90 gives us 60 there. So 14 sine 60, you then use your calculator to get that expression. And when I do that, I think I get 12.124 ... So I've got OB, I've got DN. If you look at the diagram, then the distance of D above the ground, or the height of D above the ground, is equal to 16, which is OB, to the center of the circle, and then plus 12.124, which gives me together 28, I'll just say 28.1 meters to 3 significant figures. And 9 part C says, here's a sketch of the graph of 16 minus 14 cos x. P is the highest point on the graph. work out the coordinates of P. So x is the angle that we saw in the diagram. H is the height of the chair above the ground. So work out the coordinates of P, the highest point. Well, P, the highest point on the graph, that's the greatest value of H. And the greatest value of H occurs when you're at the very top of the circle there. That's P. And that height, all the way to the bottom, to the ground, is equal to 14 plus 14 plus 2, which is 30 meters. And the angle corresponding to P, measured from the bottom, is going to be all the way around to there, is 180 degrees. So I can say that corresponding at the point P, we've got an angle of 180 degrees and a height of 30 meters. So the coordinates of P are 180 and 30. Question 10. There's 2x squared minus 12x plus 22 can be written in this form, where a and b and c are positive integers. Work out a, b and c. So I take factor of 2 outside. I get this. Now that's not really what I want, because I want to get it as a number times a bracket squared. Now I think I'll be better off if I just have the x squared minus 6x inside the bracket, and the 2 times 11, I'll leave that as 22 outside the bracket, because this is called completing the square. I can look at this and say, this looks familiar. It looks like x minus 3 squared. But if I do x minus 3 squared, I get x squared minus 6x, but I also get a term plus 9. So I'll have to subtract 9 to get back to x squared minus 6x. Now I've still got the plus 22. So that equals 2 times the bracket x minus 3 squared, and 2 times minus 9 is minus 18, and plus 22, which I can simplify further. I've got 2 times x minus 3 squared, and then minus 18 plus 22 is plus 4. Now I've got it in the form that they asked for, where we've got to work out the values of a, b and c. So the number in front of the bracket, a, is equal to 2. The number inside the bracket, x minus b, is x minus 3, so b is 3. And the remaining constant c is 4. Use your answer to part A or otherwise solve this equation. We look at the left-hand side, it's the same as what we started with in 10 part A. So the left-hand side, I can write it in my new form of 2 brackets x minus 3 squared plus 4. That's just another way of writing the expression. And now we're told that put that equal to 7. So if I put it equal to 7, let's see what happens. I can write that as 2x minus 3 squared equals 7 minus 4 is 3. Now I can divide by 2 on both sides. I get x minus 3 squared equals 3 over 2, or 1.5. So x minus 3 all squared, or x minus 3 rather, take the square root of both sides, it's going to be the square root of 1.5, plus or minus, don't forget the plus or minus. Square root can be positive or negative. So x equals 3 on the other side, take the 3 to that side, plus or minus the square root of 1.5. And now I can go to my calculator and see what I get. 4.22 if I take the top value with plus, and if I subtract the square root of 1.5, I get 1.78 to 3 significant figures. So those are my two solutions for the quadratic. Generally speaking, a quadratic should have two solutions. Two hollow boxes are made with card. The boxes are similar cuboids. The smaller box has a height of 20 centimeters. There you are. It takes 69% more card to make the larger box. Work out the height h of the larger box. Similar is the important word here. So we can use our ideas of similarity and enlargement. So from the small box to the large box, we've got to increase it by 69%. So if I call that A1 and A2, the surface area of the whole box. So the smaller surface area is going to be increased by 69%. So if you increase something by 69%, that means you multiply it by 1.69. So the area is multiplied by 1.69, so the area scale factor is 1.69. But if I know the area scale factor, I can work back to the linear scale factor, of what happens to the lengths, the linear scale factor. Instead of doing anything else, the linear scale factor is just the square root of 1.69 or 1.3. Because if that's the linear scale factor, the area scale factor is obtained by squaring 1.3 to get 1.69. So h is 1.3 times the original length or height of 20 centimeters, which gives 26 centimeters for the height of the second box.